Three students made multiple weighings of a copper cylinder. We're given the accepted value here, and it's asking us to describe the precision of Colin's measurements. So Colin's measurements is in the first column, and since it's only asking us to describe the precision, this number here, this accepted value, is irrelevant because precision refers to the reproducibility. In other words, how close are the measurements to each other, not to the actual or true value. All right, there's a couple ways we can do this. A very common way is to use, for a sample size this small, is to use the standard deviation formula, is where you take your individual measurements and take the difference from the mean or the median, you could do, depending how big your sample size is and how they're scattered. Anyway, you square that, take the sum of all those values, put it over the sample size minus 1 and square root that. We're going to take a simpler approach, and the simpler approach is just getting the mean and expressing the range as plus or minus. Now range, what I mean by that is not the biggest measurement from the smallest measurement, but the range of the farthest measurement to the mean. All right, so let's get the mean first. So we're going to add up all four of Colin's numbers or measurements: 47.13 plus 47.94 plus 46.83 plus 47.47, and then divide all of that by 4. The sig figs are just going to be the 4 digits. All right, so it's 47.3425, but we can't use, we gotta stop here. That's all the precision we have, plus or minus the range. Now, to get the range, I'm going to pick the biggest number. It looks like it's the second weighing, right, and see how far that measurement is from the mean. All right, so I got that number stored in my calculator. I'm going to press minus 47.94. So I'm going to get plus or minus 0.5975, but I can't have all that. That thing is going to round to, all right, let's keep my answer to the hundredths. The unit is grams. All right, that may not be my final answer. I'm going to do the same thing with the lowest measurement. Looks like that's my lowest one. Go back in my history, get that 47.3425 number and subtract it from the lowest number now, 46.83, and that's going to give me plus or minus 0.5125 or 0.51 grams. Now I'm not going to use that number because it won't include my biggest measurement, or Colin's biggest measurement. So I have to use the biggest, this number over here. That's going to be my precision, or Colin's precision. So I'll try to illustrate visually what this looks like. All right, so weighing one, well, let's put the mean here. The mean is not a measured number, it's a calculated number, so that's my 47.34. We just added the 4 divided by 4. All right, so there's my there's grams again. Okay, the farthest one, the weighing 2, is like up here somewhere. The lowest one is down here, not quite so far down. This is definitely not drawn to scale. And then this weighing 1 is slightly below the mean, so maybe right there, and this weighing number 4 is slightly above it, so maybe over there. So those 4 dots represent Colin's 4 measurements, and that line is, this line is the average or the mean. And so if we go up, all right, 0.6, and we go down 0.6, all right, what we're saying that expression right here, all right, includes just all of Colin's measurements. What we're also saying is if Colin were to make a 5th measurement, a 5th weighing, then the chances are very likely that he's going to get within this range.